Example, find T pre-image of 1 to 3 for T is mapping from V2 to V3 defined by T of x1 x2 is equal to x1 x2 plus x1 comma x2. Now its solution. See, here T is mapping from V2 to V3 and T of x1 comma x2 is defined as x1 x2 plus x1 comma x2. First of all, we will check that whether our 1 comma 2 comma 3 belongs to range of T or not. If it is belong to range of T, then we will say that the solution is exist. Otherwise, we will say that the T pre-image of 1 comma 2 comma 3 is 5. So first of all, to find T pre-image of 1 2 3 under T, we need to solve this equation. We need to solve the operator equation. T of u is equal to 1 comma 2 comma 3 for u is equal to x1 comma x2 belongs to v2. See, first of all, if this 1 comma 2 comma 3 if belongs to range of T, then we can say that x1 plus x2 is equal to 1 comma 2 comma 3 and x1 is equal to 1, x1 plus x2 is equal to 2 and x2 is equal to 3. Here our x1 is 1, x2 is 3, but we are getting x1 plus x2 as 2. So how is it possible when x1 is 1 and x2 is 3? So it is 3 plus 1 4, and here we are saying that x1 plus x2 is 2. So see, if I am putting x1 and x2 in this, then x1 plus x2 is equal to 2. But if I put value as 1, here 3, so this become 4. So we know that 4 is not equal to 2. So here we are saying that the sum of these two is 2, and here we are saying that sum of these is 4. So this is, both answer are not possible since both are not equal. So we can say that 1 comma 2 comma 3 does not belongs to our range of T. So this kind of solution is not possible. Therefore, T of u is equal to 1 comma 2 comma 3 has no solution. Therefore, if it has no solution, then T pre-image of 1 2 3 under T is nothing but 5. See, now from this question what we can conclude, if our range T, any element is not belongs to range of T, then we can say that it has no solution. So there are always three possibility. One, either it has unique solution, either or infinite solution, or it does not have solution. So we have seen two type of question. First, if nullity of T was not equal to theta v, then we can say that non-homogeneous equation has infinite solution. Here, if this v naught does not belongs to range of T, then we can say that T does not has any solution. Now for third option, let us see one more question. Now next example, find T pre-image of T is mapping from V3 to V3 defined by t of x1 comma x2 comma x3 is equal to x1 comma x3 comma x2. Now solution. Here it was 1 2 3. So solution. Again t is mapping from v3 to v3 defined by t of x1 comma x2 comma x3 is equal to x1 x3 comma x2. Now the associated homogeneous equation, equation is t of x1 comma x2 comma x3 is equal to theta v3. Now this is nothing but x1 x3 and x2, which is equal to 0 comma 0. So from this we can say that x1 is equal to 0, x3 is equal to 0 and x2 is also equal to 0. Therefore nullity of t is nothing but is Hebb's trivial solution, which is 0 comma 0. Now if 1 comma 2 comma 3 belongs to range of t, then non-homogeneous equation has unique solution. It has always happened that if this element belongs to range of t, then non-homogeneous equation has unique solution. So non-homogeneous equation has unique solution. Now t of u is equal to 1 comma 2 comma 3 and t of u is nothing but x1 comma x3 comma x2 is equal to 1 2 3. This implies that x1 is equal to 1, x3 is equal to 2 and x2 is equal to 3. Therefore our u naught is nothing but 1 comma 3 comma 2. This is the unique solution of non-homogeneous equation. Therefore the t pre-image of t pre-image of 1 to 3 is nullity plus t, but nullity is nothing but 0 0 element. So we can say that this is u naught plus nullity of t, but u naught were 1 3 2 and nullity of t was 0 0 0. So this is 1 3 2. So we have seen our three type of question. First, when our fixed element does not belongs to range of t, then our non-homogeneous equation has no solution. Second one, when nullity of t has unique solution, has trivial solution, that is 0 0, then non-homogeneous equation has unique solution. And third one, when nullity of t has non-trivial solution, then our non-homogeneous equation has infinite solution. Now we will see the theorem on this example. Find the t pre-image of (1 2 3) under the linear transformation t v3 to v3 defined by t of x1 comma x2 comma x3 is equal to 1 by 2 x1 plus x2 plus x3 x1 minus 1 by 3 x2 x3. Now solution. Here our mapping is T, which is from V3 to V3 and defined by T of x1 comma x2 comma x3 is equal to 1 by 2 x1 plus x2 plus x3 x1 minus 1 by 3 x2 comma x3. The associated homogeneous equation is H is T of x1 comma x2 comma x3 is equal to theta v3, now which is equal to 1 by 2 x1 plus x2 plus x3 comma x1 minus 1 by 3 x2 comma x3 is equal to 0 0 0. Now from this x1 by 2 plus x2 plus x3 is equal to 0, x1 minus 1 by 3 x2 is equal to 0 and x3 is equal to 0. So we get x3 is equal to 0. Now from this x1 plus 2x2, since x3 is equal to 0, so this is equal to 0 and 3x1 minus x2 is equal to 0. Again if we solve this, then if I multiply this by 3, then this become 3x1 plus 6x2 is equal to 0 and this is 3x1 minus x2 is equal to 0. This implies on changing sign this get cancelled, 7x2 is equal to 0. This implies x2 is equal to 0. Now my 3x1 is equal to x2, so x1 is equal to 0. So here we are getting x2 is equal to 0, x1 is equal to 0 and x3 is equal to 0. Therefore x1 is equal to x2 is equal to x3 is equal to 0. Hence nullity of T is equal to set of all 0 element. Now again here our nullity of T is only 0 element, so our solution is unique. Therefore if we are saying that if 1 comma 2 comma 3 belongs to range of T, then the non-homogeneous equation has unique solution. Therefore T of x1 comma x2 comma x3 is equal to 1 comma 2 comma 3. Therefore x1 by 2 plus x2 plus x3 comma x1 minus 1 by 3 x2 comma plus x3, sorry, it is comma x3 is equal to 1 comma 2 comma 3. So from this x1 plus 2x2 plus 2x3 is divided by 2 is equal to 1. 3x1 minus x2 divided by 3 is equal to 2. x3 is equal to 2. Now x3 is equal to 2. I will put value of x3 in this. So x1 plus 2x2 plus 2 into this is 3. 3 is equal to 2. So x1 plus 2x2 is equal to 2 minus 6, which is equal to 4. Therefore x1 plus 2x2 is equal to 4. This is our new equation. Now 3x1 minus x2 is equal to 6 and we have already value of x3 which is equal to 3. Now on solving these two equations, if I multiply this by 3 or if I multiply this by 2, so this become 6x1 minus 2x2 is equal to 12 and this is our, these are two equations. So on solving these two equations, x1 plus 2x2 is equal to 4, 6x1 minus 2x2 is equal to 12. This get cancelled. 7x1 is equal to 12 plus 4, 16. This was minus 4, so this is minus 4. So 12 minus 4 is 8. Therefore, x1 is equal to 8 by 7. This is our second value. Now on putting value of x1 in this, we are putting value in this. So 2x2 is equal to minus 4 minus x1. So minus 4 minus 8 by 7. So x2 is equal to 1 by 2 of this. 7 4s are 28 and 28 and 8 minus 36 divided by 7. 2 ones are 2, 2 18s are 36. So x2 is equal to minus 18 by 7. This is our third value. Therefore, u0 is equal to x1 comma x2 comma x3, which is equal to 8 by 7 minus 18 by 7, 3 is the unique solution of t of u is equal to 1 comma 2 comma 3. Therefore, t pre-image of 1 to 3 is 8 by 7 minus 18 by 7 and 3. This is our solution. Next question. Example. Find the t pre-image of (1, 2, 3) under the linear transformation. T is mapping from V4 to V3, defined by T of x1, x2, x3, x4 is equal to x1 minus x4, x2 plus x3 and x3 minus x4. Solution. So first of all, we will find associated homogeneous equation form, and then we will find nullity of t. The associated homogeneous equation H is t of x1 comma x2 comma x3 x4 is equal to theta v3. So this is x1 minus x4, x2 plus x3, x3 minus x4 is equal to 0 comma 0 comma 0. Therefore x1 minus x4 is equal to 0, x2 plus x3 is equal to 0, x3 minus x4 is equal to 0. This implies x1 is equal to x4, x2 is equal to minus x3 and x3 is equal to x4. Here x1 is equal to x4, x3 is equal to x4 and x2 is nothing but minus x3. So from this we can say that x2 is equal to minus and x3 is equal to x4. So minus x4. Therefore nullity of t is equal to all x1, x2, x3, x4 belongs to V4 with condition x1 is equal to x4, x2 is equal to minus x4 and x3 is equal to x4. This is equal to, here our x1 is nothing but x4, x2 is minus x4, x3 is x4 and x4 is x4 only. This belongs to V4 and all x4 belongs to R. Again we can write this as x4 1 minus 1 1 1 such that this x4 belongs to R. That means this factor can be written in the linear combination of this. So this is, from this we can say that nullity of T contain only one element. This is 1 minus 1 1 1. Therefore nullity of T is equal to this. See here, our nullity of T has other than 0 solution. So we can say that if 1, 2, 3 belongs to range of T, then non-homogeneous equation has infinite solution. Therefore T of x1, x2, x3, x4 is equal to 1, 2, 3. Now this is x1 minus x4, this is x2 plus x3, this is x3 minus x4, which is equal to 1, 2, 3. So x1 minus x4 is equal to 1, x2 plus x3 is equal to 2, and x3 minus x4 is equal to 3. Now we have to solve this equation. There are lots of ways to solve. One way, you can substitute one by one in each equation, then you can solve. Then solve 2, 2, then see, we have studied 3 types of method to solve any algebraic equation or any linear equation. So here one method is substitution method, another method elimination method, then you can solve this by matrix method also. So here we will see, we'll use substitution method. So x1 is equal to 1 plus x4, x2 is equal to 2 minus x3, and x3 is equal to 3 plus x4. So I can substitute value of x3 over here. So 2 minus 3 plus x4. So this is x2 is equal to 2 minus 3 plus minus x4, which is equal to minus 1 minus x4. So simply we can see this, x1, x2 and x3 all depends on value of x4. That means as my x4 varies, accordingly x1, x2, x3's value get changed. So here we can see this, that there are infinitely many solutions for our given operator equation. It depends on x4. So we can see this. Now I have to find one particular solution. Therefore if I put x4 is equal to 0, see, as I have already told you that we will consider standard value. So in that case, if we have two unknown, then we will put one as 0 and another one as value 1. And if we have only one variable which is not known to us, then we will simply put it as 0. It is fine if you put x is equal to 1, 2 or any value, but I am writing here x4 is equal to 0. So if x4 is equal to 0, then my x1 become 1, x2 become 2 and x2 become minus 1 and x3 is 3 and x4 is already 0. Therefore u0 become 1, minus 1, 3 and 0. Therefore the complete solution of the equation, T of u is equal to 1, 2, 3 is the linear variety of (1, minus 1, 3, 0) plus we have kernel of T as 1, 1, 1 minus 1, 1 and 1. This is the T pre-image of T of u is equal to 1, 2, 3. So this is our solution. This is the way here which you can solve any operator equation. You just have to follow 3 steps. First of all, find associated homogeneous equation, then find nullity of T. Then if you are getting nullity of T as 0 element only, then non-homogeneous equation has unique solution. If you are not getting nullity of T as 0 element, then we will have non-homogeneous equation has infinite solution. And if element 1 to whatever be the unknown v naught, if it does not belongs to range of t, then simply we will say that it does not have any solution. So this is all about how to solve operator equation.